Okay, ladies and gentlemen, your lesson for today is all about scatterplots and how the points or the variables associate with each other that we can see visual when we do get a graph. Scatterplots are graphs that use points to display numerical data. Okay, you won't see categorical data like you will with a bar graph. It's always just numbers for each of the axes. And that's why sometimes we call this bivariate data. The BI is the prefix that means two different variables that we're looking at the data or the relationship or the association between them. We can sometimes tell if one variable has an effect on the other, and we can pay attention to trends, patterns, or again the association between the variables. So guys, our first example is about Susie going to the mall. She's asked her shoppers to see how many items they purchased. You see how the bottom axis is labeled very well, and you can see that each box represents one item. And then what she did is she asked them how much they spent on those items. So this axis is obviously set up different because the money is spent, and we had to be able to accommodate some of the data which shows that they spent like $190, I guess, for this point out here. So if you realize that each of these dots represents one of the shoppers that she surveyed, again, this shopper spent $190 on 10 items. You've got another shopper right here in the middle that bought 6 items and spent a little over $120. And then, of course, this person here bought 2 items and spent $20. So understanding how to read the graph is super important, that you're paying attention to the labels on each axis. If they ask you how many shoppers she surveyed, you basically just need to add up all your points. So it looks like we've got 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I've got 16 here. That means each of the 16 people she asked about reported how many items and reported how much money was spent. Very similar to the dots that you put on your graph out in the hallway. Each dot represented one bit of your information that we took down the other day. So down at the bottom, we're also asked if the number of items purchased seems to have an effect on the amount of money a shopper spent. Well, to me, it looks like the smaller amount of items were relatively low priced. You've got a couple points that are kind of high here at this low end. But in general, do you see how the points tend to fan out in this direction? If I took my pen and I tried to cover up as many points as I could, yeah, I've got a couple points on the outside of my pen, but in general, the trend is, as the number of items increased, the more money that was spent in general. Okay, so yes, in general, more items meant spending more money. So you always want to make sure you're using the values from your graph to explain what's going on in this situation. Now guys, this note sheet needs to be turned over so we can talk about the different types of association that are common. The one we just looked at, number of items and price, was a positive relationship, kind of like this graph here. Positive variables move together in the same direction. Either they both increase or they both decrease, and that's shown by this type of graph right here. So if you remember slope dude, puff puff positive, you're going to remember that this scatter plot shows a positive association. And then this guy here, nice negative, remember? The points are going downhill, and that is a negative association. As one variable increases, the other decreases. And then this graph shows the points all over the place, okay? There's no spot that I could go and connect a whole bunch of the points and have it show the trend that you saw with the other two. So we say sometimes your variables have no association between each other. It doesn't seem to be any rhyme or reason with the basic amount of points that you have. So sometimes you're going to see questions like this. You're going to have a scenario instead of a graph, and you're going to have to think about that scenario and see if you think it has one of the associations that we just talked about. So this one, if we compare the number of hours a person studies and the number of states they visited, the time you spent studying actually has absolutely nothing to do with the amount of states that you visit. So this has got no association between the variables. This one, however, does have an association. Typically, the number of hours that a person studies means they're practicing the material and they're getting more and more confident so that when they take the test, they will typically score higher than somebody that either doesn't study or doesn't really do any review at all. So we would say this has a positive association. The more time spent studying typically does result in a higher grade. This is why your teachers give you lots of practice problems to do. Now, down here, the hours a person studies compared to the hours they spend watching TV. If you're studying a ton, that means you really don't have a lot of time for TV. So that's one variable increasing while the other variable decreased. So if you look at it the other way, if you don't spend hardly any time studying because you're watching all your favorite TV shows, that's one thing decreasing while the other thing increasing, and that is your definition of a negative association. Okay, so sometimes if you think carefully about the variables, you're going to know what kind of association you have without actually seeing the points plotted. So now that you know a little bit about how scatter plots work and the associations go along with it, you're ready to learn about how some scatter plots can have a relationship that's linear. So just like in our last unit, if you can draw a straight line to show the trend of a scatter plot, you say it has a linear association. If the points are really, really close together, then you have a strong association. But if the points are widely spread out, it's actually considered to be a weak association. We think the points are pretty close, but not super strong. So we will refer to these as either strong or weak. Again, linear versus nonlinear. Linear would be as if you can't make a nice straight line. Maybe the points are curved, like in this example. Okay, so over here, we're going to say that this one right off the bat is nonlinear. If we were to connect those points, we really wouldn't end up with a good straight line between them like we could with these. So these two are an example where you would have a linear relationship, although one of them is a little stronger than the other. See if you can figure out which one you think has a strong relationship and which one you think has a weak relationship. Both of them are positive, so we should include that because that's what they wanted us to do. Label the type of association, the strength of the association, and whether or not it's linear. So I guess we're going backwards here. We said they were linear first. They're headed uphill, so it's positive. This one does have a kind of positive relationship because it's nonlinear. We'll just kind of leave that out. But hopefully you decided, because the points over here are a lot closer together, this is considered a strong positive linear association, and this one is considered weak because the points are a little far spread out. So down at the bottom, go ahead and pause the video for a second. See if you can pick out which graphs show linear relationships. See if you can determine if they're strong or weak, and then whether or not it is linear. When you're done pausing and answering those questions, go ahead and replay and check your answers. If you said this shows a linear relationship, you're right. It is negative because the points go in this downward general direction. Remember, nice negative. But you also should say that it's strong. These points are pretty darn close together. This graph, I had some students say that it's more of a linear relationship, but I was looking at how they kind of curve down here at the bottom, which to me makes it nonlinear. And this one over here, you really can't see how any of the points line up to be linear, so we say that it's not even nonlinear, it's just no association whatsoever. We can't form a curve, we can't form a straight line or anything with our points. So, to finish our lesson today, we have some questions on the back. What I would like you to do on the back is read carefully. Up at the top, you're trying to decide what kind of association you have, how strong it is, and whether or not it's linear. Same thing we did with the graphs, but your scenarios are written out. So try those. And then down here, you're doing a matching assignment where you've got to see which graph do you think is going to represent the description that is written. So again, pause the video, try these questions, and then play it to check your answers. Okay, checking your answers. Height versus shoe size is typically a linear relationship that's positive because the taller a person is, typically their shoe size is larger. So I would say this is also a strong relationship because generally if you measure a bunch of tall people, they're going to have large shoe sizes. Now, the thing about the person's last name versus their IQ, these two things have nothing to do with each other, so this would be a no association. And the last thing is typically a negative association, and that's because if you're absent a ton, okay, typically your GPA, your grade point average, is lower because it's hard for you to make up the work. So I still said it's linear, but I'm going to go with a weak relationship because some students who are absent, when they come back, they're going to do a lot of extra work staying after and getting help that they need to still get their work done. So a lot of students that are absent can actually keep their GPA up or their grade point average. So either that or they have a tutor or maybe they're still working from home. So I said it's kind of a weak relationship even though it might be negative and linear. So on the bottom, it's very difficult sometimes to do these until you really start labeling things. So for the first question, I went with the fact that it should probably be this graph where there's nothing really related to the temperature and how much gas is being sold. People are going to fill their tanks up in the wintertime as well as the summertime. So I think this has got no correlation. So I went with number 1 being C. For number 2, I went with A because typically the bigger your house is, you're going to pay a lot more to heat your house. You're going to pay a lot more to turn all the extra lights on. You're going to pay a lot more. If you have like lots of bathrooms, you're probably going through a lot more water. So your utility bill is usually higher if you have a bigger home. Think about those shows where they have like the tiny homes. If you have a really, really small home, you don't have that much space to heat. You don't have much room in the house, basically. So I figured this is a positive relationship for part A. And then, of course, for part B, if you've ever gone hiking in the mountains, as you go higher and higher up in the mountains, the oxygen level is actually lower. So this set of points would be a good example to show that when they got really, really high up in the mountain, some of those mountains you need to bring your own air because the human body really can't breathe in enough to stay active. So part B is going to represent the altitude question. And then what you're going to do, guys, is you're going to go ahead and tape this into your notebook. I believe we are working on page 105 and 106 for this lesson.